Hello everyone, welcome to Study for Knowledge Institute. In today's video, I am going to discuss Chapter 2 Polynomials MCQs question, which is from Exemplar book of NCERT, and the content is of class 10th. Okay, so this is me, you can pause and read. So sample question is also very important because this is not something which is very coming from like giving question from you outside. It is something which is part of the chapter, so it is important to discuss these questions too. Okay, I am solving the question based on like the subjective way, but you can do it objectively because I want to make you understand, and your objective should be like in objective type of question should be to choose the correct option. Your intention and my intention is a little different. Since I am trying to solve it to make you understand, in MCQs you don't have to make teachers understand. Okay, you just have to choose the right options. Even you do the work on your rough sheet, that will work. Okay, but if I will do my like little rough work here, you may not understand, so I have to write properly. Okay, so try to focus on understanding part. Once you understand anything, it will be very easier for you to attempt the question. Okay, so let's start. Since it is given that it is a quadratic polynomial, so first write the polynomial. Okay, if 1 0 of the quadratic polynomial this is 2, so if it is given that one of the polynomial is 2, sorry, yeah, so basically I need to substitute the value 2 square plus 3 times 2 plus k. Since it is the 0, so it is going to give you the value 0. Okay, so 4 plus 6 plus k is equal to 0, so 10 plus k is equal to 0, so value of k will be minus 10. Okay, now let's move to the second question, sample question. So here we have cubic polynomial, so let's write it ax cube plus bx square plus cx plus d. Okay, ax cube plus bx square plus cx plus d. Now they are telling us that two of the zeros, like there are obviously 3 zeros are there, alpha, beta, gamma. So two of the zeros are 0 given, and they want third zeros. So how we can get that? Like alpha plus beta plus gamma is equal to minus b by a. Okay, and two of the zeros are already 0. 0 plus 0 plus gamma is equal to minus b by a. Okay, so gamma is equal to minus b by a, so the third 0 is minus b by a, that is option a. Okay, now exercise 2.1. If one of the zeros of the quadratic polynomial this is minus 3, then the value of k, the way we did sample problem 1. Okay, so we will write this k minus 1 x square plus kx plus 1. The zeros is minus 3, so k minus 1 minus 3 square plus k minus 3 plus 1. Okay, and this value will be equal to 0 because this minus 3 is the zeros of the quadratic polynomial. Since minus 3 whole square is 9, so you will be getting 9 k minus 1 minus 3k plus 1 is equal to 0. If I simplify, 9k minus 9 minus 3k plus 1 is equal to 0. So I will will be getting 6k minus 8 is equal to 0. 6k is equal to 8. So I will be getting k is equal to 8 over 6, that is 4 over 3. Okay, so answer you will get is 4 by 3. Answer is A. Okay, now a quadratic polynomial whose zeros are this. So you know how to convert, like if zeros are this. So you remember alpha, like x minus alpha and x minus beta. So here alpha is what? My bad. What is alpha here? X minus of minus 3 and x minus 4. So you will simplify this, x plus 3 and x minus 4. If I simplify this, I will get x square minus x minus 12. So I think the answer will be half of x square minus x minus 12. That is option C, because here minus is not matching anywhere. So the only way it was matching, so I got it very easily. If I take 1 by 2 out, it will be x square minus x minus 12. Okay, so answer is C in this case. Okay, if zeros of the quadratic polynomial this are 2 and minus 3, then so px is given to you as x square plus a plus 1 x plus b. If I substitute 2, I will get 2 square plus a plus 1 into 2 plus b is equal to 0. So if I simplify this, I will be getting 2a plus 2 plus 4 plus b is equal to 0. So 2a plus b is equal to minus 6. Okay, now we are going to substitute minus 3 again, because this is also the zeros of the quadratic polynomial. So p minus 3 will be minus 3 square plus a plus 1 minus 3 plus b is equal to 0. So minus 3 square will be 9 minus 3a minus 3 plus b is equal to 0. So I will be getting b minus 3a is equal to minus 6. Okay, this is what I got. This is equation 2. So if I solve equation 1 and equation 2, let's see. So okay, I'm putting it on this side. So 2a plus b is equal to minus 6 and b minus 3a is equal to minus 6. So if I do the subtraction overall, minus plus plus, this will get cancelled, this b will get cancelled. So I will be getting 5a is equal to 0. So a value will be 0. So if I put a value is 0, what is the value of b I will get? That is minus 6. Okay, so 0 and minus 6, option D is the answer. Okay, let's do the next question. So the number of polynomials having zeros this and this are, so we know that we can write the polynomial as like minus of minus 2 and x minus 5. So this is px. So if I can simplify this, I will be getting this x square minus 3x minus 10. Okay, but this is a very special case, okay, where the coefficient of x square is 1. It can be anything, right? Obviously not 0, but other than 0. So if I write general equation of this, it will be like k x square minus 3x minus 10, and k can be anything, so there can be many values, right? I can have 1 2 3 4 minus 1 minus 2 minus 3, any value can have. So obviously the number of polynomials having these zeros can be infinite, and obviously it will be more than 3. Okay, let's move to the next question. Given that one of the zero of the cubic polynomial is this, okay, so let's write the polynomial ax cube plus bx square plus cx plus d. Okay, so this is the polynomial given to you. Now the question is, like, they have given one of the polynomial, like, value as 0. So if I put the 0 here, okay, I will be getting like this as 0, this as 0, this as 0. So overall d will become 0. Okay, so px basically reduced to ax cube plus bx square plus cx. Okay, now they are asking for product of other two zeros. So like alpha, beta, gamma are the three zeros, and they are asking for the product of other two zeros. So alpha into beta plus beta into gamma plus gamma into alpha. Let's say, and the one which was 0 is gamma is equal to 0. So wherever gamma is getting multiplied, it will give you 0. So this will give you 0, this will give you 0. Okay, and you know that this is like when you do the addition thing, you get minus b by a. When you do product of 2, then you will get c by a. So here the answer will be c by a. Okay, and if you do alpha, beta, gamma, in that case you will be getting minus d by a. Okay, so here you are getting 0, and you also know d is 0, so it is valid too. Okay, so answer is c by a, option B. Let's move to the next question. If one of the zeros of the cubic polynomial is -1, then the product of other two zeros. Okay, same problem. Okay, so alpha into beta plus, okay, earlier it was getting 0, now it is not, so you have to use this method. Okay, so see, first write down the polynomial, that will give you the picture properly. So px is equal to x cube plus ax square plus bx plus c. Okay, if you substitute -1, you will be getting 0. Okay, -1 plus a minus b plus c is equal to 0. So if I solve for c, I will be getting b minus a plus 1. Okay, now the product of other two zeros it is asking. So I know alpha into beta into gamma is equal to the last term, that is this, that will be minus c over a. Like here a is the coefficient, like in general when we write ax cube plus bx square plus cx plus d, in that way. So in this case minus c over 1. Okay, and we know that one of the value of 0 is -1, so I'll be substituting -1 here. So the product of other two I will get also, that is minus c. Minus will get cancelled, so alpha into beta I will be getting is b minus a plus 1. Okay, b minus a plus 1, option is a. Okay, let's move to the next one. The zero of the quadratic polynomial this are, so here alpha plus beta is -99, and alpha into beta is equal to 127. Okay, so here summation is negative and product is positive. It means that both has to be negative, right? Only in case of negative and negative negative product negative will give you positive, and negative summation will give you negative. So both are satisfied, so both are negative. Okay, let's move to the next one. 0 of the quadratic polynomial this. So let's say x square. So polynomial given to you is x square plus kx plus k. Okay, so alpha plus beta is equal to minus k, and alpha into beta is k. If both are positive, let's say both are positive, so what will happen? If both are positive, so minus k will be greater than 0, but here if I take care of this negative, so k becomes less than 0. If both are positive, so this is also positive. Okay, one is saying k is greater than 0, other is saying k is less than 0, so this is contradictory. So both cannot both be positive. So answer is A. Let's see why answer is not B and C and D. Okay, now if I say both are negative, okay, so then I am saying minus k is less than 0, so k becomes greater than 0. Since both are negative, so product will become also positive, so k greater than 0, so both are true. Okay, they are always unequal. So like they are always unequal means like alpha not equal to beta in that case. So it can happen, there is nothing wrong in it. Are always equal, so like they are saying alpha and beta are equal. So if I write alpha and beta are equal, so it will become alpha square is equal to k, and 2 alpha is equal to minus k. So yeah, there is nothing wrong in it too. Like something which is contradictory to the natural way of mathematics. Like what is natural way? Like if I say 5 is less than 4, so it is wrong, we know that. Okay, 5 is less than 4 is wrong, we are aware, very much aware that 5, so something which is very known to you. Okay, question number 9. If zeros of the quadratic polynomial thus are equal, then. So let's see. Px is equal to ax square plus bx plus c. Alpha plus beta is equal to minus b by a. Okay, and alpha into beta is equal to c by a, and they have given that zeros of the quadratic polynomial are equal. So they are equal. So if they are equal, so I can assume 2 alpha is equal to minus b by a, and alpha square is equal to c by a. Okay, now it has to have positive, like c by a can never be negative, right? Because alpha square is a positive number. Okay, alpha square is a positive number, and c by a can never be negative. So c and a has to have the same sign. So answer is C. If c and a have opposite signs, so this will give you negative. Okay, b, like b is not making much difference here, because alpha will be what, minus b by 2a, whatever the value it is. If we do the square, we will be going to get the positive value. So here b is not making much difference. Here c and a is the playing the part. Okay, so the answer is C. Question number 10. If one of the zeros of the quadratic polynomial of form is the negative, the other is the negative of the other. Okay, so here px is given to you as x square plus ax plus b. So if here alpha plus beta is given as minus a, and alpha into beta is given as b, like minus a by 1 and b by 1. Okay, now here we have this. So it is given that one is negative of the other, so I can assume like alpha plus minus alpha is equal to minus a. Okay, so a will be minus a will be 0, so a will be 0. Okay, now I know that one is the negative of the other, so I will be getting alpha into minus alpha is equal to b. Okay, so minus alpha square is equal to b, so alpha square is equal to minus b. Okay, so 1 is 0, like here a is 0, so it becomes x square. Okay, and plus b, and b value is negative, then only it is, so has no linear term, so linear term obviously is gone because a is 0. The constant term is negative, so b is negative obviously, because if b is positive, so this will give you negative, and a is alpha square is positive, so yeah, so answer is a. The last question, which of the following is not the graph of the quadratic polynomial? When you have quadratic polynomial, okay, this is also the part of quadratic polynomial, this is also the part of quadratic polynomial, this is also the part of quadratic polynomial, this is not, because here we have 3 zeros, so this is the part of cubic polynomial. Now you will be saying, sir, where they are touching it? So in this case, although they are not touching it, but it still have 2 zeros, which is of imaginary nature. When you will go to class 11, then you will be learning the roots. Quadratic and complex number is a like single chapter. Okay, so in this case there's a repeated root, so this is also quadratic polynomial. Okay, this is also quadratic polynomial, this is the cubic root, so answer is D. Okay, so thank you for watching the video. So if you like the video, please like it, and if it helped, please subscribe and share among your friends, that will be helpful. Okay, bye.